Hey there, welcome to the second development log of the Walking Simulator engine. The goal of this engine is to create dynamic living worlds. These worlds are a kind of interactive digital painting that deliver a relaxing and active or passive engagement experience. Players can choose to watch the stories unfold with minimal or even no interaction, or they can choose to help guide the stories indirectly by influencing the world with omniscient powers. Or they can dive in and take direct control of any character at any time and influence the stories with hands-on actions. I've been working on this engine for a number of years now. They're mostly in the form of standalone minigames intended to test features in isolation. For the engine itself, it's really early days. I'm not even ready to call it an alpha release yet, but it is progressing well. I am putting super early builds out, and so I've started to talk about the development as a result. My goal in these devlogs is to ask you for your early feedback. Feel free to comment below or join the Discord, which is linked in the description. Let's get into it. This development cycle is focused on the ability to stream from in-engine to YouTube. In addition to the player interacting with the world, stream viewers will be able to influence the world and the AI characters within it by sending commands via chat. Initially, this feature will be used by me to show off the engine during development. However, we have some big plans, but it's not time to talk about those just yet. We'll come back to some details about this in-game streaming later. Let's first take a quick look at some of the other cool features in this release. The game universe consists of many worlds connected by interdimensional portals. By interacting with these portals, characters can have a variety of experiences. In earlier versions of the game, these experiences were represented by arcade machines, but these hardly conveyed portals to other worlds. It just didn't fit. While we're not currently focusing on visual quality, we did decide we needed a better placeholder for these portals. They've now been replaced by these glowing and pulsating particle effects, certainly more in keeping as placeholder art. Previously, these portals were only available to a player controlling a character. The AIs were not aware of them. We felt it wasn't fair for the AI to be unable to independently have fun, so in this iteration we wanted to change it. Since the AI system we built is utility-based, this was pretty easy to do. It was achieved by simply adding an interactive item script to the portal object. By configuring the type of interaction and the effects of an interaction on the character, the AI system will automatically choose to go to the portal when the resulting effect would maximize the utility function of the AI brain. We'll dig into the details of how this works in a little while. But the simple version is that the portal interaction results in the character's happiness increasing by up to 20 points. Since there is an existing desire to keep happiness above a threshold of 70%, we don't need to do anything to the character itself. Existing calculations will automatically detect the availability of a portal near the AI, and these will be factored into the utility calculations. We can see the result in action here. We've enabled the debug UI, and in the bottom left here, you can see the character's current stats. I've reduced the happiness level to 0. This significantly increases the likelihood that the character will look somewhere to get a happiness fix. Having spotted the portal, the AI makes her way over to it and gets her fix. You can see the happiness rising now. This feature was a great test of the flexibility of our AI system. We're super happy with how it turned out. Of course, it's not really as simple as this for all interactions, so we'll take another look at this in a moment. While working on the portals, we saw an opportunity to resolve another issue that was bothering us: the light levels at night. In the previous iteration, our characters went to sleep at night and the nocturnal creatures came out. However, if there was no moon or the night was cloudy, we found that the light levels were too low and the player was left watching a blank screen. In time, characters will make camp, light torches, build fires and so on, but we need a solution that worked before this was coded up. It dawned on us that now that portals were a magical energy, it made sense that they would emit light. Simply throwing on a light source and adding a script to make them flicker added a reasonable amount of interest to the nighttime scene without any significant effort. This led us to another new feature. If the portals were to emit light, wouldn't it make sense that the characters, without other light sources, would sleep near the portals for safety? The characters already have the desire to be well rested, with 2 rest options available to them: sit and rest for a while, or sleep for the night. However, as currently coded, the character would go to sleep anywhere, once they were tired enough. We needed a way to encourage them to seek out the light of portals at night and sleep there. Once again, the utility AI system makes this easy to achieve. First, we added an interactive item script to the portal with a type sleeping spot. Sleeping at this spot will increase the character's energy more than sleeping elsewhere. Consequently, when available, the character will prefer this kind of sleeping spot. However, unlike the portal interaction, this is the first time we've added a sleep interaction, so we have more to set up this time. We add a generic interaction behavior component to the REST behavior set. This is the previously mentioned set of behaviors that are made available when the character is tired and needs to rest. We configure this new behavior so that it is only available at night. In order to tell the character how to act when this behavior is chosen, we add various actor cues which are used to trigger appropriate animations and sounds, etc. These cues are automatically called by the AI system when instructing the character to act. Using them, we can create a series of animations and sounds that match the interaction. To ensure that this option will be selected in preference to sleeping rough, it's given a higher weight. This means that if the character is tired enough and cannot find a sleeping spot, they'll still opt to sleep rough. But how does the character know that an interactable is available? Well, you may remember that when we added happiness to the portal, we added an interactable item script to that object. This script defined changes that would occur if the character interacted with the item. In the case of the portal, their happiness would rise. In this case, we set the energy to increase when using the sleep spot. To make the sleep behavior on the player aware of the sleep spots, we simply define the effects that are desired by this behavior. The AI then uses this information to match behaviors to interactable items. In this case, we want the energy after interaction to be greater than the start energy. Since this is what the interactive item script is offering, the behavior will have a higher utility. This approach ensures that we are not coupling the character to specific interactable items, in this case the sleep spot. That is, the AI doesn't really care what the interactable item is, it only cares about the fact that it will raise energy if interacted. This kind of loose coupling makes for a much more scalable and manageable interaction system. However, we are aware that there is currently a tighter coupling than we would like in the animation system. We'll revisit this in the future. There's a couple of less critical settings to work with, but that's the core setup needed. For testing, I wrote a little terminal script to make the character tired and set the time to night. As you can see here, it worked perfectly first time. We're super pleased with how easy it is to configure this AI system. Everything we've looked at so far is merely the icing on the cake. The primary goal for this iteration was actually in-game streaming to YouTube. This wasn't initially something I'd planned for the game, but Ocular Malice on our Discord posted some interesting experiments that he was doing on interactive live stream games. It got me thinking. Our goal with the Walking Simulator engine is to create a living, breathing world where AI characters act both independently of the player and in direct response to the actions of the player. When playing the game locally, the player can influence the world in one of two ways. They can take direct control of characters, or they can take godlike actions that influence the world as a whole. In playing with Ocular Malice's experimental game, I realised that we could stream the game to YouTube and allow people in chat to influence the world in the same way that a local player would do. This would mean that players working through a storyline could stream their experience, while viewers could help or hinder them through world interactions. Since we already had an in-game terminal for testing world-influencing actions, I realised I could write a script to read and parse the YouTube livestream chats. If it found a command, then this would be fed into the in-game terminal. This would give online viewers direct influence on the game and the story within. During this iteration, we've laid the groundwork for this feature. The basics are all in place now. You can start a stream from within the client, and viewers can issue a minimal number of commands. But this is just the beginning. As we add more storytelling features, players will be able to influence the flow of the story, creating a dynamic and interactive narrative experience. We will start streaming this work sometime in the not too distant future if there's interest. We're super excited about the possibilities of bringing the streaming audience into the game world itself, and hope that some of you will be able to help us test this out and evolve the idea.
Okay, that's it for today. Hit the subscribe button, hit the notification bell, leave a comment, let me know what you want to see, let me know if you don't like what you're seeing. Thanks a lot, see you soon.